Okay, here we go. Chemistry 1121. Alright, so we're going to go through pages 1 to 8. We're going to do it real quick. Alright, just going to kind of give you a breakdown of all of it. So we're going to be talking about chemistry, obviously, what chemistry is really. So whenever we think about chemistry, we think about like complex formulas, experiments, like the mad scientist in the lab. That reading on page 1 talks about that. Kind of what our idea of the chemistry is. So, in your reading, it talks about boiling cauldron. So, a cauldron is just a large kettle. It's a big, giant bowl that is cooked with. And then the scientist is mixing chemicals indiscriminately. So basically, he's just throwing in a bunch of stuff without considering what the differences is or what the possibility of the results are. He's just throwing it all in. So chemistry is more organized than the mad scientist that you see on the page. Chemistry is experiments and scientific equipment in a logical and a careful way. Logical and careful way. Basically, chemistry is science that deals with the structure and composition and properties of matter and the transformations that matter undergoes. All right, that's on page 1 in your reading material there. So, chemistry is the structure, how matter is put together. It's the composition, what matter is made of. It's the properties, the characteristics of matter, and the transformation, the way that matter can be changed. All right, so the specific definition of chemistry is in your written material, and it's number 3. All right, so then when you flip over to page 2 in your reading, you're going to talk a little bit about pure chemistry and applied chemistry. So pure chemistry is focused on gaining knowledge simply because we want to understand something better. There may not be an immediate practical use for the discovery. So it's just having the knowledge just to have the knowledge. I want to know why, and I want to know how this works. But applied knowledge takes the chemical knowledge and looks for ways to use it in the real world. So pure chemistry is just wanting to know it. Applied chemistry is wanting to know it so that you can apply it into real life. How can we use this discovery to do something useful? All right, that is on page 2 in your reading. And it will answer questions 4 and 5 in your written part. Okay, so the 6 branches of chemistry is organic chemistry. So you're also going to have to give the definitions of these over on the next page, on page B of this. But organic chemistry studies materials that contain carbon. And not every carbon containing substance is considered organic. So, organic chemistry studies materials that contain carbon, but not every carbon containing substance is organic. Inorganic chemistry studies materials that generally do not contain carbon. Biochemistry, your third one, studies chemical processes in living organisms. So the chemical process in living organisms. Nuclear chemistry deals with the changes involving the nucleus of atoms. Physical chemistry, it studies matter and chemical changes using principles involving things such as energy and the physical behavior of matter. And analytic chemistry focuses on identifying substances and determining what they contain. All right, so physical is what you can touch. It's the energy. It's the physical behavior of the matter. The analytic is basically an analysis of it. All right. So how do you know which branch of chemistry is being studied? There's two ways to study. You study by the type of matter being studied or the method used to examine the matter. That answers questions 6 and 7 in your reading. There's a little pink box in your reading there. If you'll read it, you can answer number 8 about what contains carbon but are classified as inorganic compounds. Because remember, organic compounds study what has carbon, but not all of the elements that have carbon are organic. Some of them can be inorganic. All right. It says over on page 2 the word pathological, and what is it referring to? I think that is referring to the resulting from diseases. The word pathological is connected to a disease. If something is described as pathological, it means it is a result from or related to a disease. All right. So now over to page B. Basically did page 10 through 15 just now. And so we'll move on down to 16. Okay, so inorganic chemistry produces a new metal alloy because this branch deals with metals and other materials that generally do not contain carbon. So that is inorganic chemistry. That's on page 2. The next one, to determine why a specific reaction only occurs in the presence of light. That would be your physical chemistry. Because physical chemistry studies how energy affects chemical reactions, since light is a form of energy, therefore physical chemistry. All right, so the organic chemistry, we already talked about it in here, but it's to synthesize a new fabric from petroleum. That is in the last sentence of the first paragraph under the inorganic chemistry. Discovering a new element. So to discover element 110, that would be a new element. That's going to fall under your nuclear chemistry. Your analytic chemistry obviously analyzes. So analyzing a sample of water to determine if it contains lead, that's analytic chemistry. All right. So then on page, it's over on page 3. So I'm on question 22. Over on page 3 in the nuclear chemistry section, there you have the question, the tools of a nuclear chemist might include, so obviously nuclear chemist, so it's under that section. Your answer is going to be in that last paragraph of that section. Nuclear reactions often occur very large amounts of energy, so nuclear chemists use special equipment to accelerate particles. All right, 23. The reaction produces heat. So exothermic is going to produce. Exo is going to come out. You're going to produce heat. Endothermic is going in, so you're absorbing the heat. So when we're outside in this 100-degree weather, we're absorbing all of that heat, and we get super, super hot. All right, quantitative versus qualitative. Quantitative is going to determine the amount, how much is there. Quantity is how much. So quantitative is amount, it's in a percentage. You're answering the question, how much is there. Qualitative is looking at the kind of components. So what kind do you see, what is there, that thing. So qualitative is what kind. What is the quality of what you're looking at? Quantitative, the quantity, how much. of what you're looking at. The logical sequence used to solve an analytic problem. That's at the bottom of page 3. It is the scientific method. So then over on page 4, we're going to talk about the scientific method. Oh, I skipped a question. Oh, because it's in the scientific method. So question number 28, and then we'll flip over to page C. Facts related to the problem are gathered by, this is in the research part on page 4. How is it gathered? How are facts relating to the problem gathered? All right, so 29 through 34, well, actually 29 through 41, they're pretty much all going to be on page 4 and page 5. You might actually have to read for understanding, but we will go through it. You have to memorize the scientific method. It is going to be on the test, and it's going to be like in other parts of chemistry as well. So you have to memorize what the scientific method is, what's the process of it, okay? All right, so the reading on question 27, the reading says when scientists state a problem, they should state it clearly and concisely. Concisely meaning communicating something briefly and specifically without adding unnecessary information. All right. When scientists research a problem, they need to gather facts and information. According to the reading, facts are gathered through research, learning what other people have already observed, observation, making your own observation, and experimentation, performing controlled investigations. So you should be able to answer question 28 with that answer. All right, so any scientist researches a problem, the information is gathered and organized. Using that information, the scientist proposes a possible solution to explain what is known. That possible solution is called a working hypothesis. Hypothesis is not the final answer, it is an idea that still needs to be tested. Okay, so remember, a hypothesis is a possible solution. Okay, so the trip example on pages 6 and 7 demonstrates what a theory is. After a hypothesis has been tested repeatedly and has proven to be correct, a theory can be formulated. The book, your reading material, defines a theory as a general principle or solution that explains or solves a problem. So on pages 6 and 7, after repeating testing, the idea that chartering a bus was the best way to travel from Memphis to Flagstaff, the person could formulate the theory about the best transportation method. Theory equals an explanation supported by repeated testing. Okay? A theory that continues to pass repeated testing and has no conflicting evidence may eventually be called scientific law. May potentially be called scientific law. All right. The reading says a theory becomes a scientific law when repeated experimentation and observation consistently, supports it. So the progression is hypothesis, testing, theory, scientific law. All right. On page 5 of your reading, the scientist in the example compiles all the research. To compile means to gather information together and put it into one organized account. Compile equals collect and bring together. Page 8 will give you the answers to page 33 and 34, and that's just the thoughts to remember. It's going back to that that practical application there. But because humans can make mistakes, scientific ideas can sometimes be incorrect and may need to be changed when new discoveries are made. The reading points out that people are fallible, meaning they can make errors. All right, so that is on page 8 in that one thought to remember. So the reading calls a person's preconceived ideas as presumptions. A presumption is an idea or belief someone already has before interpreting information. So your opinion, basically. according to the text on page 8, these preconceived ideas can influence how a scientist interprets observations and data. Perceived ideas is presumptions. All right, so your true and false questions paid on number 35 through 41. All of these answers are on page 4 and page 5. Okay. And obviously there are 4 of them that are incorrect. But they're in the reading on page 4 and 5, and it's all in that in the scientific method sections. Okay, so it's like the top of page 5, not under that scientific method in action. None of the answers are in that. All right, so then over on page D, it wants you to put the scientific method in order. Y'all can do that. You have the book. So practical application to consider, and it wants you to consider what are some things that you would need to pay attention or to look at if you were to mail a student to Flagstaff. So the 2 things that we have are the safety of the patient of the student would be they could get injured in the transportation and the handling. If you've ever been in the mail room, you see how they just kind of toss things around. You could be tossed and land wrong, or you could have something heavy tossed on top of you, injury. Another thing would be the food and the water and the bathroom breaks. The students are human, so we need food to survive, we need water to survive, and we have to empty our bladder somewhere besides ourselves. So it says on page 7, yes, that mailing a person could take up to 7 days. So we can't go 7 days without food and water. And then on number 53 is what's the difference in how an evolutionist would look at a bone fossil that they found versus what a creationist would see. So an evolutionist would basically be like, hey, look, there's rockets formed over many, many, many years, and it's fossilized. It's going to be considered the remains of a living being or a living organism. It's going to show evidence of how living organisms change and evolve over time, whereas a creationist is going to look at that and they're going to be like, hey, that has been created by God. It had this rapid burial because of some catastrophic event such as the flood, and that's why it is in the ground and it is fossilized like that. So you could think of some other stuff on your own, but that's pages A through D of your chemistry 1121.